Hello, my name's Eric Dickey, and I've been involved in the geothermal, geoexchange, or what we actually prefer to call it, the energy exchange business for many years now. Started out way back doing installations, moved on to some more solid design work, got into the training side of things, and have done training all across Canada and the United States, speaking at various different universities, conferences, etc., and continued to stay quite connected to the day-to-day operation of the industry. So I think I've got a fairly good grounding in terms of what goes on with everything. This particular video is focused somewhat on a aspect of what we've done, and that is as the Western Canadian distributor for the Nordic line of heat pumps manufactured by Maritime Geothermal. And a few of our dealers have suggested that maybe they'd like to have a little bit of an update, overview, whatever, in terms of the whole idea of comprehension and troubleshooting of what goes on in the heat pumps. And so we thought that ultimately putting together a few videos, or at least a series of videos, would be a good way to deal with that so that they could take a look at them in various times and pause, review, etc., to have all that come together. That then led to the idea of making the video series a little bit more widely available, because while this particular series is based on the concept of the Nordic line of heat pumps in particular, the components, the structure, the control system in particular are very similar, whatever model of heat pump or line of heat pump it is that you're going to be looking at. So we believe that this has much more widespread application than just the Nordic line. And so as you'll see then, this becomes available a little bit more widespread than just our dealers. And with respect to that, we are going to take a look at the system, as I mentioned, in a series of videos to have it broken down into somewhat component by component, or at least section by section, to understand what goes on with it. We're going to start with this introductory video with the high voltage side. And high voltage just because that's where the power is initially introduced into the system. Ultimately, where we're looking to go is understanding all that happens within the electrical portion of the heat pump in particular, because not only is that an area where it's critical that you understand it, but also the electrical system has diagnostics available within it that will help you trace down other problems that might be showing up. It's very much a fact of life in our industry that often it's not the heat pump itself that creates a problem. It is something outside the box, whether it be circulation pumps, filters, distribution systems, whatever the case may be. Often, as I say, it's not the heat pump itself that creates the issue, but if we understand what goes on within the heat pump, it'll definitely help us to diagnose and to trace down what that problem is. So our objective, our narrow objective within this particular little video segment, is to do two things. One is, as I mentioned, to look at the high voltage side. The other is to do a real solid overview of the concept of schematic diagrams and how it works to use those schematic diagrams to not just take stabs in the dark, but to take a logical approach to the whole troubleshooting, problem-solving approach to things, and have those come through. So one of the things that I'd suggest is that you pause the video, go to our website, that would be deltageothermal.com, under the training link, and download this diagram that you see on your screen so that you're able to follow through and kind of point your finger at it. Or more particularly, a very solid tip with schematic diagrams is to use highlighters. And particularly if you're on a job and doing a trace through things, it's very helpful to be able to highlight exactly what you've checked and what you're confident is right. And ultimately, of course, the objective might be to figure out where things are breaking down. So the highlighter and the printed schematic diagram, really good things to have. So what we're going to do is begin up in the upper left-hand corner of our diagram here, and note that what we've got showing up here is three terminal points. We've got L1 and L2 and then N. Now the meaning of those would be L1 would be line 1 coming in, L2 is line 2 coming in, and if we were to take a voltmeter and measure across those two, we should see somewhere in the range of 230-ish volts. Now that voltage is not hard and fast. It's going to fluctuate depending on the area that you're in. It's going to fluctuate depending on the time of day, etc. So we want to have about that 230, 240, or in some instances 208 volts. But it's not, if it's 234 volts, we don't see that as being a problem or an issue at all. Now, having said that, we should back up a little bit and say, this instructional video isn't attempting to teach the safe use of the voltmeter. Do note that we're talking fairly significant voltage, and even more critical from a safety perspective, there's a fair bit of amperage behind these, depending on the size of the heat pump, etc., and ultimately, of course, the size of the breaker that's feeding that, but lots enough amperage to be dangerous. Not to scare you away, but it's not something to jump into unless you have that understanding of the safe use of the voltmeter, etc., or it could be a trouble light as well, although certainly from a technical perspective, the voltmeter is probably more widely used. But do be safe. Across the L1 and L2 then, if we were to measure that with our voltmeter, we're going to have that 230 or so volts. What the neutral wire does is it splits the legs, the L1 and the L2, in half effectively is what it comes to there. And so if we were to measure between the neutral wire, which will typically be a white wire, the lines feeding L1 and L2 are almost certainly going to be black and red. The order doesn't matter. It could be red on L1 and black on L2 or vice versa. It really makes no difference at all because they're both seeing that, or at least you're seeing the 240 volts between them. And then again, between the neutral wire and either one of the lines, we're going to see 115 volts showing up. So what this does with this 3-wire input, it gives us the option to pick off 230 or so volts for components that are going to run on that kind of voltage, and also allows us to pick off 115 volts for components that are going to operate on that lower voltage. So one of the key things then about reading a schematic diagram is to be able to follow things through. And so we want to come up with the idea of being able to come along that L2, for example, and note that it's coming to this terminal point. The neutral line, it's coming over to this terminal point, and L1 again, of course, is coming over to this terminal point. Now, what we see here then is the compressor contactor, and actually that's where these wires are going to be fed into. The electrician is going to bring the line wires in, tie them into the compressor contactor, and compress the screw down to hold them solidly in place. And I stress that because that's fairly important that that be done effectively. We don't want to have those loose at all. The compressor contactor itself, we're going to get into details about that in another video, but for now, what we really want to think of it as is a big switch. And another term for it, by the way, that you might be more familiar with is a relay. And it's a magnetic switch. And in this particular case, what we've actually got, to fall back into some electrical jargon a little bit, is a triple pole single throw switch. Now what that really means is that if we look at this, there is a switch there, another switch there, and again a separate switch there, hence the triple pole. And each one of those is going to be somewhat independent from the other, but they are all going to act simultaneously. And the fact that we call it a single throw switch means that it is either off or on. And what's happening within this compressor contactor or relay is that there's going to be a magnetic coil, and when that magnetic coil is energized, it pulls the contact terminals into place with each other. And as I said, we're going to look at how that magnetism part of it happens in a separate video. But for now, all we have to think about is the fact that when this thing is actuated, what's going to happen is that we're going to have continuity between the left-hand side and the right-hand side on each one of those terminal points. So ultimately then, when the compressor contactor is actuated, we're going to have 240 volts showing up between this lower terminal on the right-hand side and the upper terminal on the right-hand side. And we're going to have 115 volts available to us between the middle terminal and either one of the upper or the lower terminals. So we've got that ability to gain to draw 240 or 230, whatever it happens to be in your particular area or particular time of day, off on that right-hand side when there's a call for compressor action. And so if we follow that through, recognizing that if we were to put our voltmeter between there and there, we've got 240 volts. If we follow this line, the red line on the diagram, across and over to the compressor structure, we'll see that it is indeed feeding the compressor. Similarly, if we follow the other line, it's going to come over, and again, when the compressor contactor is actuated, it's going to show the compressor power on this side. So what we need to have for that compressor to operate is that potential voltage difference. We would be able to measure across between those 2 points. They are actually buried a little bit in terms of the contacts, but theoretically we could measure across those 2 points, and if we don't see that 230 or 240 or thereabouts voltage, we would know that there's some issue about the voltage getting to it, and the compressor simply would not work. It's not going to happen. So the switching action then of that compressor contactor is real important. If it doesn't get switched, then of course power doesn't get delivered to the compressor and nothing's going to happen with it. Now, as well as feeding the compressor, we'll see that these lines are coming over and feeding the run and the start capacitor, and that the potential relay is actually triggered by that as well. It's also seeing the voltage showing up there. We're going to leave those for a second. They are in place to help the compressor do its thing, but without getting into too much in the way of detail right at this point, we just want to focus on the idea of the schematics. Are we getting power where we're supposed to get power, and how is that operative, and how could we check it and see what's going on? So again, measuring these things with a voltmeter to see whether the power is getting to wherever it should be will give us a whole bunch of information. For example, if we were to measure voltage at between this point and between this point, because we always have to see two sides of voltage, and we've got 240 volts showing up there, but then we come across and measure to between this point, and we don't have 240 volts showing up there, that narrows our problem down quite significantly. It's the compressor contactor, or it's something that is not actuating the compressor contactor the way it should be. So again, the whole process of problem solving is one of narrowing things down, figuring out where the problem comes from, figuring out where the breakdown in the circuitry in fact happens. So we look toward that. Also, we are certainly on the geothermal system. We're going to want to run our circulating pumps at the same time as the compressor is operative. And so what do they do within the heat pump structure? Well, they pull off a line from L1. You'll notice that they're attached to the same effective terminal point there. And coming up, and let's just follow this line up, you'll note that it goes to that terminal point, but then critically it loops over to this one. And similarly, off the L2, we've also got that branching off and coming over and feeding this. So note that those are going to be hot again when the compressor contactor is pulled into play. So when that happens, we've now also got a 230 or so volt potential difference between those two terminals, and the electrician at that point can wire in the circ pumps to those terminal points. And of course, what's going to happen is that they're going to actuate when the compressor is brought into play, and I guess also only actuate when the compressor is brought into play. Now, additionally, on the Nordic line of heat pumps anyway, with the de-superheater structure, it comes as a standard on them, and also standard with that is a built-in circulator pump. But it's a 115 volt circulator pump. So what do we do to make that run? Well, instead of pulling off the power from the L1 and the L2 terminal, we in this case are pulling it off the L1 and the neutral. So now what that domestic hot water circulator pump operating the de-superheater structure, that is, of the refrigeration system, is operating on the 110 volts. There are a couple of other switches that are in place there, one that effectively turns it on, and the other which turns it off if the water temperature gets high enough, I guess probably would be a good way of saying it, so that it only brings the superheater system into play when there is both the supply of heat available to it and when there's the need. There again, that becomes perhaps a more specific topic for totally another video, but that gives the general drift of it, certainly from the overall perspective of the schematics at any rate. And so once again, at the risk of overstating it, oh yes, pardon me, I should back up and say we also might want to run a pump or whatever 115 volts. Well, there again, if we come up to this point off L1 and come from the neutral to this terminal, now we've got 115 volts between those 2 points, and we can run any accessory that requires 115 volts and also should run when the compressor is running off those 2 terminal points. That covers then the right-hand side, if we want to call it that, of the compressor contactor. If we go back over to the left-hand side for a minute, you'll notice that there are a couple of connection points that are happening here, and those are going to be sending power down to a couple of other components. And a critical thing to note there is that those are going to be constantly hot, or at least they're going to be hot whenever the breaker is turned on, so that we're feeding power in through L1, L2, and the neutral wire. So when that breaker is on, then we're always going to see a potential difference of the 230, 240 or so volts between that terminal and that terminal. So what they're doing is pulling that off, and in this line here, if we follow it, we're coming over and feeding the blower motor. Similarly, off the L1 terminal, we're also coming over and feeding the blower motor. Why are they constantly hot? Well, it may well be that we want that blower motor operating when the compressor is not. We may just want to have a certain amount of air circulation, just moving air around to effectively balance our heat distribution in the room. Or it may be that the auxiliary heat is coming on, and or emergency heat, I guess in this case, and so we want the blower motor to trigger with that. Well, we're supplying the power to it so that those options are available to it. When it comes on and how it comes on is going to be controlled by the low voltage system, but we are indeed seeing that we've got that 240 volts available to it continuously, so that creates the drive structure that's possible within the blower motor. Also, leading off those L1 and L2 terminals, we've got lines coming over to a very, very important component, that being the transformer. And so I'm going to scroll this down just a little bit so we can follow that a little bit more completely. And so again, you'll notice that off that L2 terminal, we've got the red wire coming over, and it is feeding, in this particular case anyway, the left-hand side of this transformer. And also coming off the L1 terminal, the black wire is coming over and feeding the other side of the transformer. And, is it critical that the red be the left and the black be the right? No. All that's critical is that we have a potential difference between the 2 terminals on the transformer of something in that region of the 240 volts. So these lines then are feeding 240 volts to what we call the primary side of that transformer. And what happens within the transformer structure, and we'll look at that a little bit more completely in another video as well as to exactly how that takes place, but what happens within the structure of the transformer is that 240 volts is stepped down to 24 volts. And again, it would be 24 volts AC as opposed to DC, so it's alternating current. So when you are checking this, you're going to have your voltmeter on the AC scale. But what that does, by stepping the voltage down, it creates a whole segment of the system that we can operate a safer, with less amperage, lighter duty wire, and probably most particularly, it allows us to bring into play the whole digital control side of things that is going to operate on that lower voltage. So that becomes a major component in the whole process of things. That transformer, it's the liaison, if you like, between the 240 or high voltage side at any rate and the low voltage side, which really is what does the actual control side of things. So that is an overview, at least, of the high voltage side. And hopefully as well, it does dial in that business of being able to do the schematic diagram following, tracing it through, getting more comfortable with that. The more schematic diagrams you work with, the more readily you're going to be able to move through and nail down those potential problems and have things come together that way. A couple of other things that may be valuable, certainly as I've mentioned a few times, there are going to be other videos in this series that you would be able to dial into and ultimately then get the whole picture of what goes on within the whole structure of the heat pump. Similarly, we have a book that we've published that has actually received very good reception. We're now in our third edition. The third edition, we've gone with complete color on it, and it is called Energy Exchange, Geothermal Exchange and Beyond. There is, again, a link to that on our website with a table of contents showing and a few sample excerpts from the book so you can get a sense of the writing style. We've had some, as I said, I mentioned, pretty good reception from it. One of the things that people have very frequently commented on is the readability of it. They can find that they sit back and can somewhat relax with the concept and have it step through fairly slowly and readily. Hopefully we've done some of that with this video as well, and look forward to potentially meeting you again on other videos or perhaps in person if we haven't already done that, and all the best.